Hello and I welcome you for the today's discussion. I'm myself Vishwanath Auti, and today we are mainly discussing about water requirement of crops. Water requirement of crops. In this we are mainly discussing about what we mean by duty, what we mean by delta and base period. Then we are discussing relations between these three terms. Then variation of duty with the places of its measurements, then some other terms and important questions. So here first we have to understand what we mean by duty. So duty here, if you see, duty represents the irrigating capacity of a unit of water. So the term is very important. Here they have given a relationship between irrigating capacity of a unit of water, right? So for example, if I take one bottle of water, right? So how much area it can cover for irrigating, right? So here it is, can take 1 liter of water, right? So that is the irrigating capacity. It indicates how much area can we irrigate, right? But how much water is required for irrigation for the complete growth? That is what they are telling. It is a relationship between the area of a crop irrigated and the quantity of irrigation water required during the entire period of growth of that crop. So the water has to be supplied for the area for the complete growth, of the crop. For example, if the area is 5100 hectares, right? So 5100 hectares, then for the complete growth of the crops in this area, it is required 3 cubics of water, right? So then the duty of that area is 1700 hectares per cumex, right? So that is 1700 cumex, that is total area divided by duty. You will get per cumex how much area it can cover, right? And the discharge of 3 cumex will be required throughout the base period. Now we will discuss, right, what we mean by base period after the delta. Then we will go for delta. So delta is the total depth of water required by a crop during the entire period of the crop. Entire period of crop is in the field and denoted by the symbol delta. Right. So delta is the total depth of water. So word is very important. Total depth of water required by crop during the entire period of crop. So entire period of crop it is. It is means from the entire crop means from planting to harvesting. Planting to harvesting of the crop, right, in the field, and it is denoted by delta. So for duty, it is a capacity of the water, unit water, then it is a total depth of water required for the complete growth of the crop, right? For example, if crop required about 12 watering, right? 12 watering means what? 12 times watering is required for the complete growth at an interval of 10 days, right? For example, it is around more than 100 days of crop, then more than 100, right? Every 10 days we have to give water to the land, right? So then water depth of 10 centimeter in every watering is required. So if you are watering, then the water should be 10 centimeter. Then the delta of that crop will be 12 into 10. So what is a 12? 12 is the total numbering of watering. So then 10 is the 10 centimeter of each watering. So 10, then it is required total 120 centimeter of water, and it is converted in meter. 1.2 meters of water is required for that complete growth of crop. Then if the area under the crop is A hectares, then total quantity will be 1.2 into area. 1.2 into area, that is 1.2 hectares in a period of 120 days. It is for only 120 days, right? Then you will get a relation 1.2 into A. Then we'll go for base period, right? After discussion of duty and delta, next important is base period. So here base period for a crop refers to the whole period. So remember this word, the whole period of cultivation from the time when irrigation water is first issued. So very important, from the time of when irrigation water is first issued for the preparation of the ground. First watering, just remember, base period means first watering to for a planting of crop to its last watering before harvesting. If I give simple word, it is first watering to last watering, that is the time in between, it is called as a base period. And what is a crop period? Crop period is for from planting to harvesting. From planting to harvesting, it is related to the crop, right? When you make a plantation, from that point to when you make a harvesting, removing of that crop, it is called as crop period, right? And base period is what? It is the time between first watering for the preparation of the land for the plantation to the harvesting, last watering for the harvesting. It is mainly related to the water supply to the crop. Next, we'll go for the relations between these three terms, right? So D, let D duty in hectares per cumex, hectares per cumex. Then delta is total depth of water supplied in meters. B is base period in days. Very simple. These are three conditions. One is if we take a field of area D hectares, water supplied to the field corresponding to the water depth delta meters will be. So here it is what? The area D hectares, right? D into the water supplied to the field corresponding to the water depth delta, right? So then will be it will be delta into d hectares, right? And this hectares meters is converted into a cubic meter, right? It is take as one equation 1. So that equation 1 is d into delta into 10 to the power 4, right? Why it is 10 to the power 4? Because it is converted from hectare meters to cubic meters, right? So then we'll go for next condition. Again, for the same field of d hectares, 1 cumex of water is required to flow during the entire base period, right? So 1 cumex of water is required for entire base period. Hence the water supply to this field is, so that is 1 cumex. B is the base period, right? It is converted into, right, 24 hours into 60 minutes into 60 seconds, right? It is in converting into meter cube, right? So then if you see the equation 1 and 2, after substituting, like me equating equation 1 and 2, we'll get d into delta into 10 to the power 4, b into 24 into 60 into 60, right? If you make simplification of this, you will get delta equal to 8.64 b divided by d. So here it is, b is the base period, d is the delta duty of the crop, then delta is the total depth of water required for the crop. Very simple. This relation is very important, and you will get many questions based on this equation. That is delta equal to 8.64 b divided by d, right? So even you can change, interchange, right? When you want to calculate a delta duty, so then delta will by b by delta, right? Simple, right? This equation is very important, right? And these are the conversions. 1 hectare equal to 10 to the power 4 square meters, and 1 cumex per day equal to 8.64 hectares meters, right? So why we converted this? Because we required in terms of hectares meters, right? So it is 1 cumex day, right? Next, so here we'll solve some problem, right? So problem is here, it is not so important, but we'll go through this. One is find the delta for a crop if duty for the base period of 110 days is 1400 hectares cumex. So here what data they have given, find the delta. So delta we have to calculate for the crop if the duty for the base period. So here they have mentioned duty as well as base period. So here 110 is a base period, that's what b equal to 110 days. Then they have mentioned duty, so that is 1400 hectares cumex. So we no need of converting units also. D is required in hectares per cumex. If you see this relations, right, D is hectares cumex, then delta is required in meters, then base period in days, correct? So then here they have given base period in terms of days and duty in terms of hectare cumex, right? So then we'll go for and we'll refer the first equation, right, which we derived here. It is 3.6. Use the same equation of 3.6, then substitute the value of b and d, right? You will get delta of 0.68 meters, and if you convert into centimeter you will get 68 centimeters. It means for the complete growth of that crop it requires 68 centimeter of water. Next, so here next problem, a crop required a total depth of 92 centimeter of water. So here they have given a crop requires a total depth of 92 centimeters, means it is a delta of water for the base period 120 days. Find the duty of the water. So here they have given base period, it is 120 days. Then they have given delta, here it is 92, right? It is in terms of meter, it is 0.92. So here they have given, if they mention depth, it is a delta, right? So then what we have to calculate? We have to calculate duty. So then use the same equation, 3.6 equation, then substitute the values, then you will get the duty, right? So that is after substituting and simplification we will get 1127 hectares cumex, right? It is a duty of the given problem. As I told, crop period, it is also some important definition. It is crop period is a time in days that is crop takes from instant of its sowing to that's of it harvesting. As I told, planting to harvesting, it is a period in between, right? Then we'll go for next, the variation of duty with the places of its measurements. So here, if I take an example, right, in the diagram they have given canal here, main canal, right? So then after the head work, this is a distribution canal, right? So you can see the arrows. It is a main canal, then it is diverted to distributory canal, right? Distributory canals. Then it is flowing towards the A. Then again it is going for near to the B, then it's going for water course, right? So here it is a main canal, distributory canal, then water course to the field, right? If I take example, there is a flow towards A, then B, then C. C is for field, right? So then here question is how duty varies from place of measurement, correct? For example, we required water for this field, right? It is at calculated and we know the duty, how much duty is required. For example, if area is 1700 hectares, right? This entire field is 1700 hectares, then for this 1 cumex of water is required, right? So same amount will release the from main canal. No. Why? Because from main canal to distribution canal there will be some losses. Then from distributory canals to water course there will be some losses. So losses will be considered. For example, for B and C, from distributory canal to water course there is the 0.1% of water loss. If we consider 0.1% of loss between B and C, B and C. So then it is different, that is 1.1 cumex water is required, correct? So then if I take again from A and B, right, so it will be total zero point 0.2, zero point 0.2 considerations. So then it is what, find two losses from A to B, then total cumex of water is required 1.3 cumex, right? So when you release 1.3 cumex of water from the main canal, then we will get 1 cumex of water for the field, right? That is what variation of duty with the places of it measurement. So where we are measuring, from in the place of A we are measuring, in the place of B we are measuring, in the place of C. C actually it is required for the crop, right? So here 1 cumex is required, but here we have to consider the losses, right? So then 1.3 cumex of water is required to release from the main canal for the 1 cumex of water for the field, correct? So then will reach at the head of the field, right? Then 1 cumex will reach. If you release 1.3 cumex of water, then it will really comes to the field 1 cumex, then it is fulfilled, right? So then if you see here how they are measuring the waters from different levels. So if take at the head of the main canal, then it is gross quantity. They have calculated it as a gross quantity. If it is measured at the head of the main canal, then at the head of the branch canal, known as lateral quantity of water. Then at the outlet of the canal, known as outlet factor. Correct? At the head of land to irrigated, known as net quantity. It is what? Net quantity. It is how much is required. For example, in the previous diagram for the field, right? So 1 cubic of water is required. That is a net quantity. Before that, outlet factor, then lateral quantity, then gross quantity. The gross quantities will be released from the main canal. Correct? So we'll go for some other terms. These are the very important terms, right, to understand. Correct? So one is very important, gross commanded area. So the word is very important. So we'll see one by one. One is gross, means total, correct, including all. Gross. Commanded means it is commanded by the canal, right, area, right. So if I take simple, right, after the construction of dam, right, if I take diagram, it is a river. Just consider this is the top view of river, correct. So then we know some like no good geological condition, and after the investigation, if we consider we constructed the dam here, correct, just example, right, it is a dam constructed, right. So then there will be water storage, correct. Here it is a water storage, correct. So then after storing water we have to use it. Then what we are doing, to use this water we are constructing canal at the both the banks, correct, from right bank and left bank. So here gross command area means, so how much this canal can irrigate the area. For example, if I take this is what total after the design, right, this much area can be irrigated with the help of this canal. Right, it is the main canal. Again, we are distributing the sub canals and tertiary canals, primary canal, secondary canal, and tertiary canals. But this much of area we can serve, and this area is called as gross commanded area. This much area is called as gross commanded area with the one of the canal. Similarly, here also, right? So here, if you see, the gross commanded area is thus the total area lying between drainage boundaries which can be commanded or irrigated by the canal system. The word is very important. Commanded means what? It is able to supply the water irrigated by the canal system. Area, total area, right? Gross means total area. Even it is uncultivated areas, like for example villages also, it is considered. It is total commanded area. So I'll repeat, the gross commanded area is thus the total area lying between drainage boundaries which can be commanded or irrigated by the canal system. The area can be irrigated means there is a possibility of water can be irrigated in gravity flow, from the gravity flow, right. And use or unused, it is all depends on the necessity, but here that area can be served by that canal. Then we'll go for related terms, one more terms. It is cultivable commanded area. So cultivation we know means it is a plantations or cropping. It is a cultivable commanded area. So it is a commanded area, but it is cultivable means here we have to understand cultivable and uncultivable. Say here if you know cultivable commanded area, and we have one more uncultivable commanded area. Okay, we'll see one by one. The gross commanded area also contains unfertile barren lands, right. So as I told, even the area can be irrigated, but it is the land is not good, not like no fertile for the agriculture, or it is alkaline soil, or local pond, villages, other area as a habitations. Habitations means that is used for human beings, or a forest, right. So that area will come as a not wasteland but not irrigated land, correct. These are known as uncultivable area, means here we cannot make agriculture, right. For example, barren land, alkaline soil, local ponds or water resource, villages and other habitations, those are called as unculturable area, even though it is commanded, but it is not suiting for agriculture, right? So then after this, from the gross commanded area, if you remove unculturable area, then you will get remaining area on which crop can be grown. So this word is very important. Crop can be grown satisfactorily, known as culturable commanded area. Right? We should not be more happy with the gross command area. Right? Why? Because even that includes villages or roads, right? Water resource, and main important for the agriculture is culturable commanded area. Right, that is what equation they have given. Gross command area is equal to culturable command area and unculturable area, right? So then again, the culturable commanded area can further classified as culturable cultivated area. Again, it is in detail discussions, right? So here you should focus on the word, each word, right? So you'll see now, culturable cultivated area. So here it is, we know what you mean by culture label, culture relabel, correct? So means it is good for agriculture, means we can make cultivation, right? Right, and in that time of period, it is cultivated, means the cropping are made, or agriculture is on the way, right? That is what it is, the area in which crop is grown. Crop is grown at a particular time, it is related to particular time, even though that is agriculture, it is suiting for agriculture, but in some particular time there is a agriculture process, and that land is called as culture label cultivated area. So then culture label means that land suits for cultivation, but it is uncultivated area. How it is, what is the difference? Uncultivated means even though it is suited for agriculture, but in some particular time it is not made any agriculture, right? That is, it is that area in which crop is not sown. Crop is not sown in particular season. Such a area is kept under cultivation due to following reasons. So why they not made sowing? Why? Because to increase the fertility of the soil, right? If you give a gap between cropping, and due to the continuous cropping, fertility of the soil will reduces. So to gain fertility of the soil, they are taking some gap between cropping. Then to provide pasture for the animals, right? Grassland, right? For the agriculture, for the dairy purpose, or like we have some it is also one of the dairy industries also good for source good income for the farmers. That's what they will give for grassland, or they will maintain pastures for the animals. Then the crop to be sown in that land has a different crop season. For example, we have a different crops, those crops will be grown in some particular season, right? We have a rabi season and kharif season, right? So rabi season crops are good for rabi season, and kharif season crops are good for kharif. If you make some difference, there will be not good yield in that crops. So that's what they are waiting for the season, right? So then to protect the land from the possible danger of waterlogging, right? Even it is for waterlogging, we know what you mean by waterlogging. It is what there is no good drainage in the soil, right? Soil voids are filled with some minute particles, right? To reduce waterlogging, they are taking some gap, right? So then we'll discuss some important questions. So here, if you see, December 2019 and January 2020, explain with a neat sketch the variation of duty with the places of its measurements. First, we have discussed with the diagram, that is main canal, distributed canal, water course, right? How we are measuring differently. That is, from the A point, it is what water released at 1.3 cumex. Then it is comes to B to C, it is what near to 1.2, and particularly when it reaches to the field, it is 1 cumex. That we have to explain. Next, in June July 2019, define duty. What do you mean by duty? Delta, base period, derive the relations between them, right? That equation we have to derive, that is delta equal to 8.64 base period divided by duty, right? right? So then December 2018 and January 2019, what are duty, delta, base period? Give a relationship between duty, delta and base period. Next, June, July 2017, define duty, delta, base period, establish relationship between them. Right? Same questions. They are asking in different way, and if you see, all are important. Whichever we discussed today, all are important, and some other terms are important to solve some problems, and we are solving in future some important problems. Right? And for this presentation, I mainly used Punimia textbook. Right? So that is irrigation and water power engineering by B.C. Punimia, Dr. Pandey, B.L. Lal, Ashok Kumar Jain, and Arun Kumar Jain. And parallelly, I use Dr. N. Balasubramanya textbook. Right. So thank you all.